So for this chapter, please, if you get confused, say something. Don't do the I'll figure it out in a day or two. If you're going to get behind on homework, please don't let it get behind in this chapter. Fair enough? Factors. We really don't get into the factoring, the meat of it, until tomorrow. So today's just kind of some groundwork. Today should be a whole lot of review from last year's Math 8 class. So, all right. So factors. Factors are numbers that a number can be evenly divided by. So factors for something are going to be numbers that something can be evenly divided by. This here. Factors are numbers that a number, you could say, is divisible. So factoring, if you stay caught up, you make the logical connections, it's not bad. So 6. You can divide 6 by what numbers and not get a decimal answer? Go for it, Jacob. Yep, 1. So a lot of times people get it this way. We called it the rainbow method before. 6 divided by 1 is 6, right? So 1 and 6 are both factors. Divide by 1, you get 6. Divide by 6, you get 1. And then Jacob had the other 2. 6 divided by 2 is 3. 6 divided by 3 is 2. So those numbers are all factors of 6. Yes? Probably not a big surprise there. 28. Factors would be 1 and 28. Somebody else give me another. 2 and 14. Anybody remember how to tell if it's divisible by 3? Okay, 2 plus 8 is 10. Can you divide 10 by 3? Nope, so you can't divide 28 by 3. So 2 plus 8 is 10. If 10 is divisible by 3, then 28 is going to be divisible by 3. So 4. Can you divide 28 by 4?
4 and 7.
Yep.
So the number's 28, so add 8.
And then, so we're almost in the middle. So left we have 5 and 6. 28 divided by 5? Nope. 28 divided by 6? Nope. So those are my factors, those 6 numbers. 1, 2, 4, awkward space, 7, 14, 28. Prime numbers are going to be numbers greater than 1. So numbers greater than 1. It's greater than 1. That are only divisible. Nice. D-I-V-I-S-I-B-L-E. Only divisible by 1 and I'm going to say themselves to keep it plural. But something like 23, you can only divide it by 1 and you only can divide it by 23 evenly. It's only divisible by 1 and 23. So prime numbers, 2, 3, 4, yes or no?
No.
Nope, not 4 because you divide it by 2. 5, yep. 6, nope, it's divisible by 2 and 3. 7,
Yes.
yep. 8,
No.
nope, really none of the evens are going to be from here on out, right? All evens divisible by 2. 9,
No.
nope, because divisible by 3. 10 is even. 11, yep. 12, no. 13, so 13.
Yes.
15, nope. 16, nope. So 17, ... So prime factorization. Breaks a number into the prime numbers you'd have to multiply to get the number. So I'm trying to take these numbers down by like 252 and saying, what prime numbers times each other will get me 252? All right, so 252, I like just going by 2s until my number's not even anymore. So you could say half of 252, half of 200 is 100.
126.
Yep, half of 52 is 26, so 126. I'm going to divide that by 2 again, and that will give me 63.
63.
63 is not prime, so you can't divide by 2, but 6 plus 3 is 9. Yep, you can divide 9 by 3, so you could divide 63 by 3, and you get 21. Some people, though, instead of doing 3 and 21, they do 7 and 9. So you have options. There's different ways you could do it.
3 and 9.
Then 3 and 7. And then once you're there, you can't divide 7 anymore. So my prime factors are going to be 2, 2, 3, 3, and 7. So if I would do 2 times 2 times 3 times 3 times 7, I should get 252. The way they write it is exactly what you're starting to say. 2 squared times 3 squared times 7. And they always do low to high. So please do the 2 to whatever power times 3 to whatever power times, but have your bases be in order from low to high. So if we were to do the same thing for 60, I'm going to break it up into 2 and 30, then 2 and then 3 and 5. So this one here, I have a 2 squared times 3 times 5. If you want to take the time to go back and circle those, you could.
12, 5, 6, 2. Yeah. And then you have to split the 6 down.
You have 12, 5, 6, and 2?
For the
Oh, okay, so you broke 60.
12, 5,
Yeah.
6, 2.
So if you wanted to, you could break it up into different ways. You could do 12 and 5, 6 and 2, 6 and 2 and 6, whatever. And then a 2 and a 3. Either way, you should have 2 2s, for your 2 squared, a 3, and a 5. So, yep, but if you want to break it up in a different order, that's totally legit. So, we okay on this stuff here?
When we save the numbers already prime.
Then that's just would be your answer, like down here in the bottom. Just be whatever that number is. So, good? Greatest common factor. When we're doing factoring in section 2 and beyond in this chapter, it's convenient if you can find that greatest thing to divide, that greatest thing to pull out. So greatest common factor, you'll abbreviate that GCF, capital G, capital C, capital F. It's the largest number that two numbers, you could say, are divisible by or are evenly divided by. Largest number that two numbers are divisible by. So basically it's the biggest number that you could divide two numbers by and not get any decimals for your answers. There's a couple ways that you could go about doing this. And we kind of did number one already. We said, well, what are the factors of a number? And we did that rainbow method. We just listed out everything you could divide it evenly by. So that's number one, is just to list all factors. So list all factors. And if you look back up at the top, essentially that was the first thing we did right in Roman numeral 1 where we had factors. The second way to get it is what we just did before this Roman numeral 2, is prime factorization. And once you do the prime factorization, then multiply all common factors. And I think this is going to be easy if you have two bigger numbers, two numbers that you can't look at and say, oh, they're both divisible by 8, and that's the largest thing you can divide them by. So what I tried doing is this. So here's the answers that we had before. So 252, we did prime factorization, we came up with this, yes? We had 60, we did prime factorization, we came up with this. So now what we want to do is we want to multiply all the common factors. What does this and this have in common? They both have how many 2's?
2.
Yep. So they both have a 2 squared. So I'm going to say 2 squared. You could, I suppose, write a 4 in there right now. This has a 3 squared. This has a 3. So we'd multiply 2 squared by 3. Because where this first one only has 1 3, I'm sorry, the first one has 2 3's. The second one has 1 3. So they only have 1 3 in common. This one has a 5, but this one doesn't. So you can't multiply by 5. They don't have it in common. This has a 7, this doesn't, so you don't multiply by 7, it's not in common. So 2 squared times 3 gives us 12. So 12 then is going to be the greatest common factor of the 252 and the 60. How are we? Are we okay on those? Yeah. All right. So kind of the last prep step before we actually do factoring in the future section is going to be to figure out, well, what's the greatest common factor of some monomials? So in other words, we want to do like what we just did up above. We want to figure out greatest common factor of like the 12 we had right here. But we want to do that where you maybe have some variables in there too. So the greatest common factor of monomials, I'm going to say is, it's like part A, which is above, and all the variables they have in common. So in other words, if we want to find the greatest common factor of 8x to the 4th and 6x squared y. So I'd look at it really like two problems. So first, what's the greatest common factor of 8 and 6? You can divide them both by 2. And you could do the prime factorization if you wanted to, but you probably can look at it, say a 2. So the greatest common factor is going to be a 2. And now how about x's? How many x's do they both have? 2. So I probably should have phrased it, x to what power do they both have? But they both have an x squared. Can we pull out any y's from both of them? No. Nope. So what we just found is we should be able to take 8x to the fourth and divide it by 2x squared, and take 6x squared y and divide that by 2x squared. You know, we could pull out that factor, that 2x squared, out of both of those. Should I show, or maybe I'll quick show, feel free to not copy it, but my plan was to go through and say, if you're going to do prime factorization, 8 is 2 times 4, 4 is 2 times 2, so I have a 2 to the third. 6 is a 2 times 3, and then I'm down to prime numbers. So you look at, well, what do they have in common? They both have only 1, 2. That's the only thing they have in common, right? So then the greatest common factor is 2 for the number. Maybe one final comment, and you could write this, you could not write this, but that 8x to the fourth, I'm going to try to pick a different color. I'm going to go for brown. Okay, 8x to the fourth, what we really found is 8x to the fourth, that's 2 times 2 times 2, that gives me my 8, 2 to the third, times x times x times x times x. Do you agree that would give me 8x to the fourth? And my 6x squared y, I'm going to write that down below. 6 is 2 times 3, and then I have a x times x is my x squared, but then I also have a y. So what we're really doing is we're trying to say, well, what's in both? So if you want to look at what's in both, well, in both I have a 2, agreed? And I have an x, and I have another x. So the thing that's in both of them is going to be a 2 and x times x, or 2 and x squared. So that's essentially what we're doing, is we're listing out how do you get those numbers and variables, and you're taking what's in both to get the greatest common factor. Does that help seeing it that way at all? Okay. Then let's jump ahead. So, all right, 20x squared and 5x to the fifth. Who sees the number? Go for it. Somebody?
I said 5x squared. That's what I said.
Okay, so the final answer is going to be a 5x squared. Because you could do 20 divided by 5, and you get an integer. You could do 5 divided by 5, so they're both evenly divisible by 5. And they both have at least x times x. They both have at least an x squared in it. We okay for that one? Questions at all? Last thing should be an application. Is that what you have on the top of the next? Must be. That's what I have here. So.
Wait, are there seriously 16 guys in front?
No, I totally made this up.
Okay.
In A class, not in our class. Yes, sir?
Oh, I was just gonna say it.
Oh, I'm gonna, yeah, okay. So if you have 16 guys, 12 girls in a class, what's the largest possible group size, with groups being all guys in a group or all girls in a group? The answer is 4. So we're trying to say, what's the greatest common factor of those? What could you divide 16 up into? Well, you could divide it up into groups of 4. And what could you divide 12 up into? You could divide that up into groups of 4. And so basically the answer to the first one is 4. Okay, and that's the GCF of 16 and of 12. We're all still on the same page? Then when they say how many groups would there be total, your answer would be, go for it, Jacob, 7. And the way you get that, we have 16 guys. We can break them up into groups of 4, which then if I do 16 divided by my groups of 4, I am left with 4 groups. So 4 groups. And then if I have 12 ladies, 4 people in a group, that's going to give me 3 groups of girls. And then I can take my groups, 4 groups and my 3 groups, add them together, and I get 7 total. Questions, comments, anything?